In this video, I'm going to introduce you to the idea of finding the limit using a table. So let's look at the question. So our example is find the limit at x tends to 2, x squared minus 4 over x minus 2. So what I'm going to do, I'm going to consider this limit. So let's consider the function. So my function is, as you can see, my function is x squared minus 4 over x minus 2. Now, what we need to do, we need to find the limit of the function at x equals to 2. So, first of all, we want to see if the function is defined at x equals to 2 or not. So, what I'm going to do, I'm going to see what is the value of the function at x equals to 2. So, at x equals to 2, my fx will be what? F2, because I am substituting x is equal to 2. So let's simplify. So I'm substituting this x as 2. So I have 2 squared minus 4 over 2 minus 2. Now, if I simplify further, as you can see, I have 2 squared is what? 4 minus 4 over 2 minus 2. Right? So, we all know that 4 minus 4 is 0 over 0 because 2 minus 2 is also 0. So, as you can see, the function is undefined. Function is undefined at x equals to 2. So, technically, this is a function which is not defined at x equals to 2. But we need to find the limit of the function at x equals to 2. So what I'm going to do, I'm going to simplify this function. So as you can see, my function is fx is equal to, I have x squared minus 4 over x minus 2. If I simplify this expression, I will write this as x minus 2 times x plus 2 over x minus 2, right? So as you can see, I have a common term at numerator and denominator, so I can cancel that out, and then if I simplify, I will get that is equal to x plus 2. So basically, the function fx, the one that I have, if I simplify, I can have the function fx is equal to x plus 2. But you need to remember that the function is not defined at x equals to 2. So what I'm going to do to explain this undefined term for the function, I am going to graph the function. So this is my x-axis and this is my y-axis. So this is my x-axis and this is y-axis. I'm going to graph the function. So this is 1, 2, and then I'm going to graph the function. And my function is like this. This is basically 2. And the function is not defined at 2, which means what? There is a gap at this point. So I have an open circle at that point, which is basically what? X is equal to 2. Because the function is not defined at that point. Right? Now, what I'm going to do, I'm going to create a table to find the limit of the function. So, this is my table. So, I'm going to draw a table. So, as you can see, this is my table. And I'm going to consider my first row as x and my second row as f of x, right? So I'm going to consider some random values. As you can see, we want to find the limit at x equals to 2. So what I'm going to do, I'm going to consider the points that are close to x equals to 2. So I'm going to consider the point on both sides of 2. So just to explain you this, what I'm going to do, I'm going to draw a number line. So this is my number line. As you can see, and if this is my 2, which is x equals to 2, I'm going to consider the points coming from the left of x equals to 2, and then I'm also going to consider the points coming from the right of x equals to 2. So the point that I'm going to consider from the left is 1.9, 1.99, and then I can also consider 1.999 because I want to be very close to x equals to 2. So as you can see, 1.999 is closer than 1.99 and 1.99 is way closer than 1.9. So basically, as you can see, I'm trying to get closer to x equals to 2. So the next point should be what? 2. And then I'm going to consider the point on the right side of 2. So my first point should be 2.001. That is very close to 2. And then I'm going to consider one point as 2.01. And then I can also consider 2.1 as my another point. So as you can see, 2.001 is way closer than 2.01 and 2.01 is way closer than 2.1. So basically the idea is to get as close as we can from both sides of the point, like the one that we are looking to find the limit at, right? So basically our point of interest, which is the point at which we want to find the limit, is f equals to 2. Now what I'm going to do, I'm going to use the function. So as you can see, my function is f of x is equal to what? X plus 2. And if I consider my point 1.9, what will I get? I will write f of 1.9 is what? 1.9 plus 2, because x is 1.9, and if I add, I will get 3.9. So at 1.9, the value of the function is 3.9, right? Now, let's consider 1.99. So I'm going to consider at 1.99, I will replace x by 1.99, so I have 1.99 plus 2, and 1.99 plus 2 is what? 3.99, right? So at 1.99, the value of the function is 3.99, right? Now, let's consider 1.999. So I'm going to consider the value of the function f at 1.999, and if I do that, I have 1.999 plus 2, and that will give me what? 3.999. So at 1.999, the value of the function is what? 3.999, right? Now what I'm going to do, I'm going to find the value of the function from the right hand side. So basically what I'm trying to say, if we approach the point x equals to 2 from the right hand side, we will hit these points 2.1, 2.01 and 2.001. So I want to see what are the values of the function for these 3 points. So the very first thing I want to do is finding the value of the function at 2.1. So as you can see, my function is x plus 2, so I'm replacing x by 2.1, so I will write 2.1 plus 2, and 2.1 plus 2 is what? 4.1. So when x is 2.1, my value of the function is 4.1. Now let's consider our next point, which is 2.01. So I will write f of 2.01 is what? I'm replacing x by 2.01, so I will write 2.01 plus 2, and if I add these two numbers, I will get 4.01. So when x is 2.01, the value of the function is 4.01, right? The next value of x is 2.001. So let's see what will be the value of the function. So I have 2.001, and at that point I'm going to replace x by 2.01. So I will write 2.001 plus 2, and that will give me 4.001. So at 2.001, the value of the function is 4.001, right? And if you remember, the value of the function at 2 was undefined. So at 2, this is when function is undefined, right? So this is the point when the value of the function is undefined. Now, if you remember, we can approach the point at which we have to find the limit in two ways. One from the left of that point, and the other one is from the right of that point. So if we approach that point from the left, we will call it left hand. We will call it left hand limit, right? We will call it left hand limit, and we also use a symbol LHL for left hand limit, right? Now, if we approach the point at which we need to find the limit of the function from right, we call it right hand limit, right? And we also use a symbol, we call it RHL, right? So as you can see, both the two values, or I should say, if we are approaching the point x equals to 2 from both left and right, the values are, if you look closely, the closer we get, the values are getting close to 4. So what will be the limit? This limit. So the limit for this function would be what? The limit of the function would be limit x tends to 2 fx, which is what? Limit x tends to 2, my function is x squared minus 4 over x minus 2, that will be equal to 4. The reason why, because closer we get from both sides, left hand side or right hand side, my limits, left hand limit and right hand limit, they are getting closer and closer to 4. So my limit will be what? My limit is basically, limit x tends to 2 is basically, for the function is 4, right? So the limit from both sides is 4, like getting close to 4. So the limit of this function is equal to 4. So we can write 4 over here, right? And this is how we'll find the limit of any given function using a table.